now that you have got a glimpse of the programming languages that were there before Java really gained its popularity, what I would wish to say is the stature of Java today in your day-to-day life. Well, can you really imagine a life without Netflix, without Instagram, without eBay, Airbnb, and a host of these apps? You know what? Java plays a major role in the development of all of these. Not just that, these applications as well. They all make use of Java. Today, it is almost unimaginable for us to lead the kind of life that we are leading without the support of Java, and that is the stature that Java has for itself in the 21st century. So, the language that you would wish to gain complete control over and also being able to be a good software developer using the language, it becomes very important for you to understand as to what are the features of this language which really made it so popular. Of course, these are the features, but what do they really stand for? Well, in this course, you would get to know about each of these features, and it is only then that you would definitely appreciate as to why Java has remained as the #1 programming language for a very long time. Java undoubtedly has attained its stature for whatever features it has, but then what I would wish to say you is that when humanity started programming, we were not programming using the high-level language. And you know what? How the programs we used to write initially look like this. Yes, we were coding using all zeros and ones. Just imagine how difficult it would have been for those early day coders to actually code everything using zeros and ones. And if you would wonder as to why it would be difficult, well, you could still be an expert who can write the code using zeros and ones. And by the way, writing the code using zeros and ones is what we called as coding using the machine level language. Though you could be an expert and code it using machine level language, the major limitation of machine level language is that we really can't understand the code. And if you can't understand the code, debugging the code becomes pretty difficult. In other words, definitely the machine level language style of coding was what was initially adopted by us when we started to program machines. In fact, we always aspired to have a machine which could do all the computations for us, and that was the actual definition of the computer, that it is a machine which could do all sorts of complex computations for us. We have come a long way from coding using the machine level language to coding using the high level language such as Java. Of course, Java is used in coding a host of these applications, but then at the end of the day, you must understand that the journey actually started from the coding in machine level language. So I would wish you to know a bit of history about all of this before I proceed ahead and tell you about how really Java is helped in creating all of these applications. So very quickly, let us see as to what really the history was. The main purpose of any programming language is to enable us, the programmers, to write programs. And why do we write programs? Well, we write programs so that it would solve our problems. And who really executes these programs? Well, it's computers that would execute the programs and hence enable us in solving our problems. Well, what it also means is that without the computers, there wouldn't have been anything called as programming, and there wouldn't have been anything called as the programming languages. In other words, even before we go ahead and learn a programming language like Java, it really becomes important for us to understand as to when the computers were invented and when really programming started in a big way. Though we have been making attempts to invent computers and solve our problems through computers right from the 19th century itself, still we found success only in the 20th century. To be very precise, it was in the year 1936 that one Mr. Conrad Zuse invented a computer called the Z1. It was an electromechanical programmable computer, which means that it had both the electrical components as well as mechanical components. Anyway, after that, it was one Mr. Tommy Flowers who in the year 1943 invented another computer called the Colossus. It was a purely electrical programmable computer, which means that it had only electrical components. Anyway, what in general you need to understand is that it was only in the 1940s that programmable computers were designed in a big way, and hence programming also took shape in a big way since 1940s. Though programming in a big way started in the 1940s, yet the programs that we wrote those days are completely different from the way we are writing programs today. Those days, we used to write programs in the machine level language. Well, a typical program of the 1940s would look like this. Yes, this is a program which is in the machine level language, which means that we used to write the programs using zeros and ones. Now, why were we writing our programs using zeros and ones? That's because the computers which we had invented had a component within it called the microprocessor. The microprocessor was a semiconductor technology device which was made up of the NPN and the PNP transistor, and it understood only 0 volts and 5 volts. Now, in computer science, 0 volts was referred to as 0 and 5 volts was referred to as 1, which means that this microprocessor could understand only zeros and ones and nothing else, and that is the primary reason why we in the 1940s used to write our programs using only zeros and ones. And such a program which was written using only zeros and ones is what we call the machine level language. Of course, the machine level language code, when given as an input to the microprocessor would happily execute it and would produce the output. But then the machine level language code put us in a lot of trouble. If you would ask me as to what is the problem associated with the machine level language programming, well, you can notice it yourself. First and foremost, understanding the code is such a difficulty. And secondly, by mistake, if you would code a 0 as a 1 or a 1 as a 0, debugging it becomes a nightmare. Not just this, a lot of other problems forced us to shift our programming from the machine level to the assembly level. And if you'll ask me, what is an assembly level language program going to look like? Well, this is how the assembly level language programming looks like. And as you can notice, it is making use of the mnemonics. And how did it simplify programming for us? Well, instead of me remembering this binary code, I could always remember the mnemonic called move. Similarly, instead of me remembering this binary code, I could remember a mnemonic called add, and similarly a mnemonic called sub. Well, if this course was meant to explain assembly level language programming to you, I would have definitely discussed this in greater detail. But since it's a course on Java, I would restrict myself to tell you that definitely assembly level language programming was a lot easier when compared to the machine level language programming. It made use of mnemonics, it made use of the registers like the AX, BX, CX and so on. Nevertheless, it made programming a lot simple. But then we had to face a challenge. What's the challenge? Well, this assembly level language code, when we gave it as an input to the microprocessor was not able to execute it. And if you'll ask me, why was it not able to execute? Well, you know that the microprocessor is made up of transistors, and the transistors can understand only zeros and ones. The transistors cannot understand your mnemonics like the move, the sub, the add, the AX, the BX, and all of this cannot be understood by the microprocessor, and hence the microprocessor was not able to execute the assembly level language program. So what's the solution? Let me tell you. Well, we obtained a solution to our problem by inventing a software called the assembler. Yes, an assembler is a software which accepts the assembly level language code as the input and would produce the machine level language code as the output. And once we obtained the machine level language code, we could give it to the microprocessor, and the microprocessor would happily execute it and produce us the required result. We as programmers were also happy because we ourselves directly never wrote the program in machine level. We wrote the program in the assembly level, which was a lot simpler than writing it in the machine level. In other words, in the 1950s, we as programmers were pretty happy because we coded our programs in the assembly level, and with the help of a software called the assembler, we were able to convert it to the machine level and obtain the required results. But then we wanted to make programming a lot more simpler, and hence in the 1960s we shifted in a big way from the assembly level programming to the high level language programming. What is high level programming all about? Let me tell you. High level language programming is all about making use of symbols and English like words in coding. Well, if you'll ask me how does the high level language program look like, I would convert each of these statements of the assembly level to the high level, and you would get an idea as to how the high level language coding looks. The first line in which I am moving a certain value into the AX register in high level can be coded like that. Similarly, the second statement in which I am moving a certain value into the BX register in high level can be coded like that. Similarly, the next two statements involving the addition and the subtraction in high level can be coded like that. And you can notice that that is what we call as the high level language programming. And you can also notice that we are making use of the symbols like the plus, minus, equal to, and also English like words such as int in our coding. And definitely I am sure all of you would agree that writing programs in high level is a lot easier when compared to writing the programs either in the assembly level or in the machine level. Nevertheless, the challenge still existed. The challenge is that our microprocessor would never understand the high level language code. You know that the microprocessor can understand only zeros and ones and nothing else, which means that we as programmers had to invent a software which could convert our high level language code into the machine level language. And hence we invented a software called the compiler. Yes, a compiler is a software which used to accept the high level language code as the input and produce the machine level language code. And this machine level language code, when fed as an input to the microprocessor would happily produce the required output. And we, the programmers of the 1960s, were also pretty happy because we never directly coded our programs in the machine level. We used to code our programs in the high level and then made use of a compiler to convert it to the machine level. So what we have to understand is that since 1960s till date, we have been making use of high level programming languages in order to code our programs. Now we need to proceed and understand which are those popular high level programming languages since 1960s till date which have made programming a lot easier for us and also a lot exciting for us. Let's explore which those programming languages are. Even before I proceed and speak about the popular high level programming languages, let me share a bit of information with you. The human brain, for some reason, is not good at remembering numbers. We, as a human species, are good at remembering the names when compared to remembering the numbers. And in fact, we are best at remembering the images. Well, let me give you an example to substantiate this. Say supposing you happen to meet a person and hence would also like to collect the phone number of the person, but then the phone number that you collect, there is every possibility that you tend to forget the phone number, and hence whenever you store the phone number of the person in your mobile, you would also be associating it with the name of the individual. That's because you remember names better than the numbers. But then there is again a possibility of you having multiple contacts in your mobile with the same name, and hence to avoid confusion, you would also probably take the pic of the person and store it in your mobile because you remember images much better than the names. So what it all goes to show is that the human brain can remember images a lot better when compared to names and can remember names much better when compared to the numbers. And this correlation is what you can see with respect to the machine level, the assembly level, as well as the high level. You can notice that the machine level was all about the binary codes, basically the numbers. And since we are not good at remembering the numbers, we invented the mnemonics. Mnemonics are nothing but the names associated with the binary codes. But then we went ahead and invented symbols like the plus, the minus, and so on, because the human brain is best remembering symbols and images. Nevertheless, I am sure all of you would agree that high level programming is the easiest and the most efficient way of coding. Definitely, high level language undoubtedly is one of the easiest ways of coding, and Java, being a high level programming language, has not just been high level, has also remained as the #1 programming language since a very long time. Now you are investing your time and energy in trying to understand and write code using Java. Definitely, by the time we reach the end of this course, you would be a lot confident about using Java, coding in Java, and I'm sure this course is not going to leave you high and dry by the time we reach the end. See you in the next session.